Hey guys, welcome to Algos Explained. My name is David, and today we are going to go over a hard level question on Edabit. You know what? I'm thinking this one might be more of a medium level question, but it is labeled hard, and it's the time for a hard question. So let's go ahead and do it. It is in JavaScript as usual, and it is called Oddish versus Evenish. Um, Create a function that determines whether a number is oddish or evenish. A number is oddish if the sum of all of its digits is odd, and a number is evenish if the sum of all of its digits is even. If a number is oddish, return the string oddish. Otherwise, return the string evenish. And it says here, for example, oddish or evenish, they're going to give us a num, and it should return evenish because the single digits in this number, 1 plus 2 plus 1, as it is shown here, equals 4, which is an even number. And if we were to be given the number 41, we should return oddish because the digits here spread apart, 4 and 1, 4 plus 1, that equals 5. And 5 is an odd number. To start off, if you don't know how to find even or odd numbers, you do it by doing the modulo. If you, just like how you would kind of determine if a number is even or odd by dividing it by 2, right? And if it divides evenly by 2 and there's no remainders, we know that's an even number. The same thing is with the modulo. When you divide a number by 2 and there's no remainder, that number modulo 2 would be 0. And so that's how you check for even numbers and odd numbers. That is kind of an essential piece of this question that you really need to know. If you don't know that piece and you came to this question, it would become very hard for you. And you know what? In algorithm cases like these, and even in interview situations, there are lots of times where you kind of have to know a piece of information or like one way to do a smaller part of the problem. And in this case, it's a very small part, and it's a fundamental part of just dealing with numbers and coding in general that we all kind of learn at the beginning stages of our career, or not career, but the beginning stages of our learning of coding. But then there are bigger pieces that come up when you do tree traversals, graph traversals. There are other strategies like that, just like how there's this small strategy of knowing how to find out an even number is even or odd. Strategies like that, they come into play, and the only way you can really overcome knowing something and not knowing something that is needed for a question at hand is by giving yourself more experience. And that comes into play where you give yourself that experience, and not necessarily, and that in part translates to, no, I'm not memorizing the answers to various questions, but because I know these smaller pieces of the puzzle, now when I face a harder question, if it's the same style, I'll definitely know it. And even if it's not the same style, I could use these tools in my toolbox to figure out the answer. So that was a little rant about just how sometimes you gotta know how to do something in order to get through a problem. And for this situation, it was knowing that to determine whether a number was odd or even, you do modulo 2. And so what's our strategy for this? We are going to we have to sum up all the individual digits, right? And how do we do that? One thing that we cannot do with numbers, the type number, is we cannot look at each index, just like how in a string or an array, we can look at the value of it at index of 0 and index of 1. But we can't do that with numbers, but we can coerce, or we can change numbers to strings very easily. And once it is a string, at that point, then we can start indexing into it. And we can also change those strings back into numbers pretty easily also. And that's kind of how we can do the sum. Before we start on this question, as I read this question, I just thought it would be a pretty interesting challenge, or maybe it's not even a challenge, but if I were giving this question as an interview question, I would actually, after the person solved it, I might throw a bonus challenge at you saying, okay, how can you give me the answer oddish or evenish without actually summing up these numbers? And in a real life situation, maybe if I throw that at you, I would probably say, just give me the strategy behind it. We don't need to code that out. If I were to give you the restriction, don't actually sum up the numbers, how would you do that? And I would kind of listen to your strategy. And if it made sense, then we would just move on to the next question or end the session. But yeah, it's one of those situations because people do throw things at you. With my last set of interviews, my first interviewer of the day, we finished his question pretty quickly, and he kept on throwing like a little bit harder constraints at me, and some of them we did end up coding it out. Others we just talked about strategy behind it, and once you start getting to those stages where you finish the question early and you kind of force the person, the interviewer, to give you an extra bit of a challenge behind that, you're in a good spot. Okay, but so our strategy for this, the initial strategy, is we're going to do the um, very basic answer of let's turn a number into a string. That way we can we can actually index into it. Once it's a string, what we're going to do, we're going to use a for loop to index into every single number of the larger number that we were given, and we're going to start adding that up together. And once we have that added up together, then we could determine is this sum an even number or an odd number, and that will give us our answer right there. And we'll talk about the answer to the challenge that I threw at you after we take a look at the code. So I didn't delete the code this time. I have it right here. And let's just go ahead and look at it. So we were given a num, and what we did here is we created a string num. This is how we're going to change the number into a string. We just use this right here. And this will change the num into a string because, of course, like we said, we're going to start iterating through the string num in order to get into the single digits of the number. And we initialize a sum of 0, and then we're going to just iterate through the string number like we said, and we cannot add numbers together. If you were to add string numbers, if you were to add a 2 and a 1 in string format, it would actually be 21. It will just stick those together. If you were to add the number 2 and the number 5, it would be 25. If it was a string, sorry, I think I said number. If you were to add the string 2 and the string 5, it would be 25. That's why we have to parse it. That is changing the string back into a number. That way we can actually start doing some of the real summing. And this for loop will iterate through the entire string number, and it will start collecting a sum for us. Now at the very end, all we have to do is we take a look at that sum. Is it even or is it odd? Like we said, we need to know this tool right here. How do we know if a number is even or odd? And we do it by doing a modulo 2. And right here, I did not use a helper function. Sometimes you might want to use a helper function in this case. You might not. If the person to me said, and we would check if this number is an even number and just throw in a function out there called isEven and put the sum in there as an argument, like if isEven with argument sum, and then had this same format, return Evenish, return Oddish, I would be like, great. How would the isEven function look like? And he would say, okay, I would just use a modulo 2 and see if that's 0. Then I'd be, okay, great. We don't need to code that, because you don't. In my experiences, every time I created a simple helper function like that, many times I did not have to actually write it, and that goes for you too. In cases where you do have to write it, most likely that you might be facing the last problem of the day. But in a particularly easy situation where you take an easy helper function and say, this is the name of it, this is what it would look like, I'll code it after I'm all done with the bigger problem. The interviewer will say, great, and maybe at the end he would say, okay, don't even bother with that, we're good, let's move on to the next one, or something like that. But anyways, you guys get the idea of here. And as I was explaining this, I remembered I did not go over edge cases, and that is very important in all interview situations, and even in Edabit situations. Actually less important in Edabit because you can actually go through the tests and kind of look. This is what I did. I was wondering, when I was answering this question, I was wondering, what if we face an odd, or sorry, not an odd number, what if we face a negative number? What does that look like? And like kind of, you would ask your interviewer this. What if it's an odd number? What if you get no number? What if you get a null value, or if you get some string value in there instead? And they might say, okay, don't worry about any other values. There's not going to be strings or nulls. And they might say, and there will never be an odd number. Don't worry about that. But you just mentioning that really brings out, I do care about edge cases, because in real life situations, the reason why our code breaks most of the time is because we didn't think of an edge case that, well, maybe your code's just broken, but sometimes, most of the times when your code is good, sometimes you'll get an edge case and you never realized, oh, I didn't account for that when I was writing the code, and now I have to get back. And interviewers like to see that you are someone who does understand that edge cases are a real thing and that you are thinking of them most favorably before you go into coding the real problem. Okay, and yeah, and I didn't sweat about the negative numbers because I went into this test cases and I saw, okay, all of them are positive anyway. So okay, so now the challenge that I gave was, how do we do this without summing these numbers? And the summing the numbers was right here. That's what we did. And kind of, it seems like it is the easiest way. It was the most intuitive way to do this question because it simply asked us, is Evenish if the sum of all of its digits is even? Because that is the easiest way to do it. It kind of gives us a strategy right there. However, if I throw the challenge at you, don't sum it up, how'd you do it? And I was kind of thinking about how these numbers worked. And if you think about odd numbers adding to itself, 1 plus 1, that's 2. But if you do 1 plus 1 plus 1, that's 3, that's an odd number. And if you just had a single digit, 1, then that's an odd number. And so if you're looking at an odd number, if there are an odd number of odd numbers, then that will sum into an odd number. If you have an even number of even numbers, that's going to be an even number. If you have an odd number of even numbers, that's going to be an even number. Kind of really quickly, I guess I'll just show it right here. 1 plus 1 plus 1 equals odd. This is what I mean. 2 plus 2 plus 2. That's pretty much what I mean. If you have an odd number of odd numbers, it's going to be odd all the time. And whether or not you kind of add those together, like if you take an odd number of odd numbers and an even number of even numbers, it's always going to be odd. The odd numbers have so much power. If you ever had an odd number of odd numbers within the numbers that you're summing up, it's going to be an odd number. And so with that kind of understanding of how the numbers sum up and kind of ultimately show themselves at the end of the day, I created this other answer where we're taking the same thing, we're taking the number and we're changing it into a string because we are going to iterate through it. We still have to look at every single number, that does not change. But I created an even count and an odd count, and I think later on I deleted the even count because, like I said, the odd numbers have so much power, even not so much. And so let's delete that part. So we had an odd count. This is really important. And so we go through the first for loop where we iterate through the numbers like we have to. And we create this if statement that is counting how many odd numbers do we have in here, because that's all that matters. Remember, we don't care about how many even numbers there are because any even number of even numbers, odd number of even numbers, that added to the odds, it's the odds that make the difference. It's the odds that decide whether the sum of the total numbers is going to be odd or not. So we only cared about odd count. And I did use a helper function this time. I used an isOdd helper function, which is right here. If, actually no, right down here, isOdd. All I did was take a num, returned num modulo 2 is not equal to 0. And that would be true if the number was odd. And it would return false if it was not odd. And so when I was coding this, of course I have to code it all out for Edabit. But in an interview situation, if you were to just say isOdd and finish writing this code, and at the end come back and say, should I write the isOdd helper function? I would say no, don't do it, don't bother. Because we know how it's going to work and we know how it works within the bigger picture and we don't really need it. And so all we do is we just check, okay, is this number odd? Remember, we indexed into the number because we can after we changed it into a string. However, my modulo counts on the fact that this is the number type. And so we do a parseInt and change that back into a number so that we can have that single digit, not as a string anymore, but as a number. And we check, is it odd? If it is odd, this will return true, right? Therefore, if true, we return the odd count, or we increment the odd count, which was initialized as 0. And so at the end of the day, if is odd, odd count. So we use the helper function again. Odd count. Remember, like we said, if there's an odd number of odd numbers, whether it's just a single odd number or 3 or 5, that sum is going to be an odd number. And the and how it's added to any sets of even numbers, that does not matter. So we said, okay, how many odd numbers do we have? Was that an odd count? And so is odd of the odd count, and if it was, then our number is going to be odd. If it wasn't, then our number is going to be even, which means if our odd count was not odd, that means there was an even number of odd numbers, which means it was like a 1 plus 1, which equal to an even number. Like a 5 plus 3, that's an 8, right? That's an even number. And so that's how we got that here. And we all know that this is probably going to work. So let's go ahead and demonstrate the is oddish even with the non-summing strategy, just to show you. And we're probably going to end this video. Hopefully, if you have any questions about this, go ahead and comment either in Edabit or on the YouTube video. And if you have requests for particular problems, I would love to do things that people have real questions about. I'm just going through the list. I'm just feeding my playlist little by little, and you know, I'm like at 2 videos in my hard playlist now, and so it's going slow. However, it's just slow and steady. If you have particular questions that you're struggling with and you kind of want to see my thought process on the strategy behind it, I try to make it as easy as possible. There are other resources here, like different math splits. I'm pretty sure all of these strategies worked well, but I like to take it to the basics, use the for loop, and usually that's fine. And in interview situations, that's going to be fine too, because the easier you make it for yourself to understand, the more success you're going to have. Especially, you don't want to trip yourself up in those situations because it's stressful enough anyways. However, I'm talking too much. Thank you for watching this video, and if it helped you, be sure to like it. If you see my video link in the comments or resources in Edabit, please upvote that. I think it helps reach more people, and I'll catch you in the next one. Bye.